Nori is a zk state bridge that allows you to move state from Ethereum to Mina in a trust-minimized way, relying only on cryptographic trust assumptions.
So we hear about bridging all over Web3. It's obviously one of the most critical functions for passing information and value between different networks. What's different about Nori from traditional bridges?
So first of all, very important one, security. Most of the bridges that exist in Web3 rely on a committee of a couple validators and basically rely on the multi-sig transition. So whenever you can get a group of validators / signatures to sign some data, and you have to ensure that they're honest, and you have to apply another logic on it. A lot of bridging will then deploy a network for just interoperability. And with Nori, those trust assumptions are totally different. With Nori, it all depends on cryptography. So worst case scenario, infrastructure of Nori goes down, anyone can move their tokens freely because all of that is secured by zk circuits, and everyone can see verification key and they can redo the same code. The code is open source, so people can just run themselves. The second thing, most of the bridges, when we talk about bridging, refer to token bridge and allowing you to move value in terms of tokens. Nori also allows that, but much more. It will allow you to move any arbitrary data from Ethereum to Mina, regardless of is it a token, is it an identity, is it another type of asset, or if it's even just a message communication.
Time to dig deeper.
One of the interesting things about Nori is you had to plug in some different systems together to get everything working end to end. It's hard enough across ecosystems, but I'd love if you could describe in some more detail how your stack looks.
The stack is divided into 3 stages. First stage is when we run Ethereum Lite client, Helios, inside the zkVM. So we do that for consensus layer update, which yields us an execution state root of the whole Ethereum state. We run that inside the zkVM, meaning that we generate a proof of this transition. Then we take this proof, which is a SP1 Plonk proof in our case, and we pipe it through our infrastructure to verify that proof into O1JS proof. We kind of call it proof conversion because it's kind of moving the proof to O1JS compatible format. After that's done, we submit it to a smart contract that holds execution state root as an on-chain state on Mina.
Earlier, when you were talking about how with traditional bridges, the infrastructure is basically its own network that's spun up with a group of validators that are then signing on the flow of information in between those networks. If that network or that bridge is exploited, or those validators are attacked in some way, it puts all the information in the funds at risk. In this scenario where we're actually using proof verification instead of signatures, it's kind of it's a reframing. And so maybe we can talk a little bit about like how that works and how the risk is a little bit different.
So that was one of the main reasons that Nori was designed in such a way. It was designed the way that all of the operation can be done by anyone. So the trust, it doesn't rely on the Nori itself, it relies on the cryptographic proofs. Meaning that if for some reason Nori infrastructure wouldn't be able to do something, there is always a possibility of doing it by cryptographic ways. It is open source, it's permissionless, so it basically gets that trust assumption, that trusted element of bridging out of the picture.
And so when you're saying that it's completely trustless, permissionless, are you saying that anybody could turn up and operate this bridge at any time? You don't have to hand over keys or anything?
Correct.
That's
correct.
incredible.
That's just cryptographic proof. So all the zk circuits are open source. So obviously Nori will have the most optimized and efficient infrastructure, and I think it will make sense for Nori to operate it. But at the end of the day, yes, cryptography allows that anyone could run it and move their own state.
You make it sound really easy. Why hasn't anybody else been able to do this across Web3?
It's a good question. I think it's due to the technical problems that there have been before. I think zkVMs also now are becoming more mature, and only now it becomes even more accessible to developers. But also Mina is the best verification layer. So we can use it to basically verify all those proving happened correctly, and we can then just settle with that proof.
I know there's been a lot of excitement in the Mina community for an Ethereum to Mina bridge. Are you at the stage of thinking yet, where your design sounds quite flexible, of opening this up to other EVM chains?
So for now, we kind of need to be focused on Ethereum due to the utilization of the beacon chain. The beacon chain gives us the option to just run the Lite client, which nicely gives us the execution state root. And also that execution state root is the finalized execution state root, meaning that there is no possibility of transaction not being included with that. That adds a latency for the user from the moment his transaction on Ethereum is getting fully finalized, but it gives us the most security. And yeah, I would love to open to more on more chains, and I think that's coming in nearby future. I think the easiest one for the infrastructure to support would be actually Cosmos.
I'm curious, Matthew, from your perspective, what makes Mina the right design or the justification for when Carol says as a proof verification layer or settlement layer, Mina fits Nori perfectly. Can you talk a little bit about the technical details and why you think that is?
The way I think about Nori is it's drawing a very clear through line from the ideas behind Mina, the way that Mina should reason about data, the reason that applications built on Mina should reason about data, through to the Ethereum ecosystem. Something they've described as one of their goals, but doing this properly, taking a full zk verified snapshot of the data, and then allowing people to build upon that, to take cryptographic views of the data and pierce into it for what they need, without having to make heavyweight transitions of all the data on chain. Mina was designed to do this well. Nori's been designed with those same principles in mind, and so the two of them work together really beautifully. The proof verification part as well, Mina is built natively for that, and so it is the right environment to push proofs to when you want to prove these sort of cryptographic views that are so important for applications to build on systems like this.
What are the properties that you get when you say Mina is built for that specific proof verification? How would you explain the properties that you get out of that?
So the goal with state bridges, and they haven't been realized well in practice so far, but the real goal is that you have different ecosystems with different information, different financial patterns, different properties as well. And for apps to be successful, if we think about the way that things are built in Web 2, it's not any one component or one system. It's a bunch of different systems working together. These state bridges are the way that we can compose these systems together. Zero-knowledge proofs are a really nice way to coordinate that composition. And what Nori is doing is bringing that Ethereum data into this system to allow us to interact with it. As we see other use cases, for example, zk oracles coming in, or zk KYC, complementing that with the data from Ethereum, the data from other ecosystems, so there are more bridges. That's where the real power of zk comes through. That's where the design of Mina will start to shine. And I think all of us at O1 believe Nori is the first shining example of this really coming into reality.
I just want to double click more on the Mina side specifically around when you talk about Mina was specifically designed for these zk systems interacting and verifying. What is the moat there? Why can't Ethereum just do this today? What makes Mina unique specifically around when we say, look, it's designed for zk? We say that a lot, but I don't think a lot of people understand what we mean. Can you talk a little bit about that?
Yeah, getting a bit more precise on that. The first obvious part of the puzzle is the proof verification. On Ethereum today, you can do similar things to what you can do on Mina very expensively and in ways where you don't have the ability to compose proofs. Proof systems that you're able to verify on the EVM, they are singular, they're standalone. It's very hard to start mixing them together. Mina is designed to be able to mix the proofs together, but also to encapsulate the state views that the proofs are about. So in the Ethereum world, you want to have as much of your data as possible on-chain so that you can do things with it, and your application mostly lives at that layer. We think that having flexibility about where you execute your application, allowing the data to come from various different places, that's the most powerful way to build applications. It's like the difference between synchronous programming and asynchronous programming. Synchronous programming makes things very easy. In the EVM model, you write your code and you know how it'll execute, but you can never make a network request. You can never ask for something to happen and see the results later. What we're pushing for with Mina is opening things much more up to the asynchronous programming world. And on Nori in particular, we're saying we're getting an asynchronous message from Ethereum, and we want to compose that with other systems, other applications. And Mina is designed exactly to support that.
The frustration over the years might have come from people seeing all these people trying to build things from a little bit more of the synchronous programming analog. And they've not been very successful because there's all these other components that are missing. But one thing that I've learned, especially in my role in kind of getting to know at least you and the others who have been designing Mina for a very long period of time, it's actually this decoupling of execution from settlement and giving settlement these properties that unlock the more asynchronous programming side. It only works for a subset of applications right now, but ultimately to scale in the long run and to provide a much richer application experience, it's necessary. And it's that zk composability is at the heart of those design decisions.
Yes. I mean, to be cheeky, you could say that because we are open about the execution environment, One of the things Nori is bringing is effectively the EVM on Ethereum can become one of the execution environments for zk programs building with Mina.
Yeah.
But in general, our principle is you need to execute some things in private, some things collaboratively, some things in whatever infrastructure makes sense for you. And we want to support all of that. We want to be as unopinionated as we can be. And building these components in the cryptographic zk way is the best way to make them composable.
Back to Nori.
We talked about first use case of Nori being a token bridge. Token balances are one form of state that gets passed over and we can do things with it. And I think that's a great place to start because it allows people to play with it and there's a demand for it. And in our specific case, it will be the first bridge from Ethereum to Mina. Help me understand when we talk about state and not just token balances, but other things. What can we do with it? What can people expect? Maybe not at the first edition of the token bridge, but down the line. And what can this look like in practice for the user?
One thing I would say to start that off is I'm really looking forward to see what developers are going to come up with. Nori will try to achieve the goal of being an SDK that allows developers to move any type of data they want, with quite few quirks that they will have to ensure that whatever they use on Solidity side makes the security assumptions of, hey, you cannot create a double spending on any site. So there will be some designs to obey by. When it comes to use cases, I think to give visual examples, I think talking about identity is quite interesting use case. There are a lot of protocols on Ethereum that already have put identity into a state. But as we know, most of the Ethereum, all the Ethereum state is public. So if you want to actually make private assumption, private facts about the identity, that's where you're hitting problems. And that's exactly where I see Nori could potentially bridge that identity or even lock for a time period that identity to run over some computation over that identity on Mina.
What does that mean in practice? Can you give me an example of what that could look like?
So for example, if we have a world ID, the identity from WorldCoin, there are multiple things that you could make proofs of. So for example, on Mina, you could prove that person has an identity, it has some particular age, and then with that proof, you can reuse it.
If I'm playing that back, I don't know how many world IDs have been created since its inception, but we can take the world ID database that exists on Ethereum, verify it on Mina, create a proof of that, and then within all of that data, we can create individualized proofs. A user of a world ID can come claim their world ID on Mina, and then let's say use it as a input to zk vote, for example.
Correct. Exactly. And what is great about Mina as well, this proof is reusable. I mean, it is as reusable as the developer desires to be. You can make it expired in some time. That's not a problem. But that also means that there's no unnecessary computation have to happen. You can take the proof and use it as long as you desire.
There's so much effort across the entire space going into, especially on the identity side, creating proofs of identity. And I think the Mina strategy is saying, in some sense, we're not going to play that game of trying to compete with all of these different proof generations. And instead, we'll verify it and we'll make a system that these proofs can be combined and reused. And then also applications that are ZK native can plug those proofs in. I like that from a scalability aspect of an ecosystem because it's not being very selective around saying, no, use World ID versus Pravado versus all of the other ones that exist. They can all work if they're proofs. They just need to be verified in a consistent way.
Yeah, it's just unnecessary computation to re-put your identity on the other network. From the user perspective, they wouldn't want to do that. Going through the hassle of actually creating it, why go through it again?
In the same vein, there's all these different projects taking different approaches on it, and they're optimizing for different things. But ultimately, what people care about is the result and being able to use it. So focusing in on that side, the situation we're moving into is once the data is there somewhere, once it moves onto Mina, you have this snapshot that you can always build off, and you know that all the trust assumptions are made. We don't have to keep reusing, recycling, rechecking the proofs. That's all done for you through Mina's recursive verification. So you can get on and actually use the data in the ways that you want to.
Can we dip into the technicals again, and can you explain the recursive properties there are that make that possible?
Ultimately, what Mina is a proof of this large Merkle tree containing views on a bunch of different applications of user states, basically data in formats defined by the different systems plugging into it. In order to get this single proof, we've had to optimize Mina as well for verifying a whole host of different input proofs. So we prove the entire blockchain. We also prove every transaction, and we allow the transactions to come with proofs. We prove that those transactions are valid as well. And by building this stack from the ground up, ultimately culminating in this single proof, you get to forget about all of the proofs that went into it. If you can reason well about the trust assumptions of all the systems plugged in, you're happy with them, then all you have to do is take this single proof and work with the data. You don't need to keep worrying about the interactions or anything like that. You have your confidence, one small package, and everything else is about the data we can get on and compute.
I know we've talked about Mina as a proof of everything in that way, but that's basically the technical explainer for how. From a application developer standpoint, if you want to come in and you want to use this data in some form, Nori is providing the infrastructure to get it there in the first place. But when we say we have the entire history of Ethereum in a single proof, how easy is it for a developer to come in and say, I want to use World ID for an example?
Yeah, that's a great question. So when it comes to developer flow to utilize that data, the process is as follows. So the execution state route, talk about that Nori is bridging. It's a root of Merkle-Patricia tree of Ethereum. In order for users to make statements about that state, they have to get a leaf, which is the actual data, and provide it as an input to one of the applications. So let me give you an example of the token bridge. When the user logs the tokens on the Ethereum site, that means that he inputs the data to an Ethereum smart contract specifying that, hey, I have logged X amount of tokens in this place. So on the Nori side, and from the developer perspective, developer will calculate the location of that data. Because of the design of the EVM, you can specify exactly the location of the data, and you can request the Merkle proof of that data from the Ethereum chain. So that will come, the Merkle proof, as an input to a zk app. When the zk app is designed correctly, it can take that input and based on the verification of the Merkle proof against the execution state route that the Nori infrastructure is updating, it can yield whatever it's required. Again, in the token use case, that will be minting a wrapped Ethereum on Mina. And the goal here is to design an SDK that allows developers to quickly find out what is the location of the data they're looking for. That will be by simply providing an ABI of the Solidity smart contract and giving back the request parameters to the Ethereum get Merkle proof endpoint. And then the smart contract, the zk app of the developer, will need to talk to the main smart contract of the Nori, which stores the execution state.
Yeah, it's
that was technical.
No, it's perfect. Yeah, no, that's what we're looking for. Because I think it's easy to be like, all of Ethereum stayed one proof. So what? What does that mean? I think that's important. What sucks about it right now? What can people expect?
Yeah.
Clearly, this is a first of its kind thing. So where's the catch?
That's very fair. Again, we designing in security in mind. So the biggest struggle from user perspective is going to be latency. So currently, because we're using Beacon Chain consensus layer of Ethereum, the finalized blocks we're getting are 12 minutes behind finalized execution layer blocks. So the moment user makes a transaction on Ethereum and he gets a confirmation in his wallet, we need to wait 12 extra minutes to get that picked up by the Nori infra. After that, we have latency of our zkVM proving, we have a latency of proof conversion, and we have a latency of uploading it to the Mina blockchain. Currently, we are sitting at around 15 minutes. And that is the least optimized route. We have quite a lot of designs. We're hoping to get to around 10 minutes, 9 minutes in the first iterations. And obviously, as Mina's locks time decreases, we will be able to get that on-chain even quicker.
So when we're thinking about that in the context of the use case itself, people can expect that it will be slow, but it will be secure. And I think we've talked about the analogy in the past of like, especially in transferring wealth when Spain was plundering the New World. This is not an endorsement of that. But they had all of this gold in the Americas that they wanted to get back to Europe. And it was a very dangerous passage because pirates would be attacking them along the way. So their strategy was to send these armadas and load 1 or 2 times per year, load up all of the gold just in one ship, and then send a fleet of 16, 17 ships around this and only do it once per year. It would take a long time. It would be really expensive, but it was better to have this guarantee of security and do it all at once rather than continuously sending smaller ships that were vulnerable to attacks from pirates along the way. And so I think the analogy here is like, it's not going to be a bridge that everyone should use right now, given that it is slow. It is going to be way less performant in terms of speed than what people are used to in bridging. Most of the world has optimized for speed. But in terms of security, it does provide this step function improvement to anything else that is out there because it's reliant on proofs. And it's not reliant on basically another blockchain that potentially could be exploited. Again, not an endorsement of those tactics as a whole, but I think like where we are right now, as long as we're setting those expectations that this is a first of its kind, it's using proofs, and the security guarantees that you can get from it are just a lot stronger than what else is out there right now. I think that's an important framing. Nice.
Let's go. Nice.